Hello, my name is Nagsaya Puraj and today I am going to talk about how we can communicate throughout the solar system. and this is my topic. Introduction. Now let us imagine if you are an astronaut and you want to send an email to people in the Mars. It will take you about 21 minutes to send a single email for this time of year because it is about 35 million or 140 million miles away from the earth without inheritance. So to solve the problems, let us brainstorm some different types of ideas which scientists have seen, which is to create a simple network across different planets. This technique is very simple. We are going to build different satellites across different planets and we are going to use the satellites to hop the signal. That is the main interplanetary communication system. But the cost of this type of system is very high, because we have to put multiple satellites on the planetaries, and different planets have different type of gravitations, and different gravitations have different effects on the communication systems which we have currently. So that is why this is main problem of this technique. We can also use, instead of using radio signals or EM signals, we can also use lasers. The lasers have small points. Lasers has small frequencies and shorter wavelengths. Thus we can transmit the signals far away without any disruption, and the data can be transmitted up to 100 times faster. The NASA Deep Space Optical Communication Project uses this type of technique, which is here we can see that it is as fast as the broadband signal on the earth. That is why they are going to use lasers. But the main problem of the lasers is that if we have any obstruction in the communication, we are going to lose some amount of data. That is the only problem of the lasers. Next is that we are going to use the probes and rovers rather than having stationary satellites on different planets. We are going to use different probes and rovers to communicate throughout the systems by using different satellites rather than having one satellite orbiting around it. We are going to have land satellites which are going to move around the whole planet and use it as a communication system. And next is that rather than using that, we have to have some kind of internet in the space, right? So the NASA has created something called as disruption tolerant networking. In this the data packets does not exist. Say that the data packets does not exist, and the data only exists at the end users, thus creating different data points at different users rather than having one data point. If we want to communicate between both of them, we have to establish a network. We are going to establish a data network between both of them rather than having data connection between everything all at once. See, this is a simple picture. We can see that this is a simple picture which I have taken from the NASA. We can see these are the different networks. These are the different planetary networks every planet has, and we are going to have different data nodes rather than having only one node. And we can communicate between different nodes. This is the DTN. Next technique is that we can use relay stations for the other planets. Satellites normally orbit planets in a Kepler orbits, which was named after Johannes Kepler, and wrote the mathematical equations for the satellite's movement. But in Europe, European British researchers has proposed putting a pair of communication satellites around Mars in something called as non-Kepler orbit, which basically means that instead of moving in circular or elliptical path around the Mars, they will be sending off, they will be orbiting bit off, so the planet does not the planet is not at the center. In order to stay in that position, however, the satellite would have to counteract the effect of the gravity, which would pull them towards the Mars. To keep them in the place, the scientists have proposed equipping them with an electrical propulsion engines to generate, by generating using electricity and tiny amount of xenon gas and the propellant, and this would enable satellites to relay radio signals continuously. Another type of method is that using breadcrumb of relays. In this, we are going to use a massive ship or some type of ship to form a chain towards the Earth, which towards the solar system or away from the solar system, which increases and passes the messages from spacecraft to Earth. The idea is that chaining the relays between the spaceship and Earth, each hops of the signal is much shorter distance than the whole distance of several light years. That is a simple method. Another method, and next is that rather than using different satellites, let us say we can use giant antennas on the receiving end. Thus maximizing the signals, thus maximizing the faint signals. We can see, instead of using starships and instead of using different bulky satellites and etc., we can increase the length of these antennas receiving different amount of signals on the Earth, which would give rise to easy communication between everything. So the project Lacarius use this technique to antennas, to see the antennas, to listen to the antennas. We can see the project Lacarius here. And next is rather than using the gain antennas, we are going to use faster light neutrophones, or we can use neutrinos. In the neutrinos, we are going to projectile neutrinos towards the Earth. Neutrinos are the small clocked particles, which are quantum particles, which carry some amount of data in them. Because they are quantum particles, they have tri-state rather than using only zeros or one, thus increasing the data level of them. And the CERN particle is tiny bit faster than the Einstein's speed limit. Thus we can communicate through the satellite using a fiber optic cable like structure by creating an undisturbed fiber optic cable like structure in the space to communicate between different particles. We can see the structure here. Something, if you want to communicate between them, we are going to use a fiber optical type structure. This is how we are going to communicate between them. This is how now let us recall everything again. We are going to use different structures, we are going to use different techniques. First technique is that we are going to create an interplanetary network. Next is that we are going to use radio signals to lasers. We are going to use lasers rather than radio signals. We are going to use probes and rovers, which move the satellite moves around on the land rather than having on in the air. The internet, we are going to, or else we are going to use the DTN network, or else we are going to build the relay satellites, or build the breadcrumb trail satellites. We are going, or else we are going to use giant antennas, and use very sensitive, super sensitive electronic ears, like this one. And we are going to use the faster, or else we are going to use a fiber optic communication. We are going to use fiber optic communication, which was created by neutrinos, which is this one. Thus, creating the main communication systems through the solar system, thus having communication throughout the solar system and after the solar system.
SpaceX launched Elon Musk's Tesla Roadster into an orbit around the Sun. Sputnik fell back to Earth just a few months after its launch, and Elon's Tesla is now the different ways we communicate with objects, all the way from low Earth orbiting satellites to deep space probes at the edge of our solar system. We're also going to talk about the equipment that's used, and how the capability of that equipment has to grow in order to deal with the increasing amount of data we are collecting from our solar system. Say you wanted to send a command to a satellite placed at a geostationary orbit 36,000 kilometers above the Earth. Firstly, the command gets converted into a radio wave, which is a type of electromagnetic radiation that travels at 300,000 kilometers per second, the speed of light. Once the command is converted into a signal, the ground station antenna will then transmit that signal towards the satellite, which will use its very sensitive antenna to receive the signal. Then, the onboard systems will convert that signal into code, which the onboard computers can understand. Most satellites will have an uplink and a downlink to allow the satellite to send data back to Earth. In 1962, NASA realized that it would need a brand new communication system for the Apollo missions. Not only would the Apollo missions be going much further than the previous missions, they would also be communicating with 3 astronauts working in 2 different spacecraft.
So that's how we are going to communicate between different satellites. That is how the base station also works. And thank you.